Welcome. The following is an introduction to the new iLEC interlocking end cap from Filmtec Corporation. For the next few minutes, we will be describing the key features of the end cap and will also give recommendations for installing and removing the interlocking membrane elements when servicing a typical reverse osmosis or nanofiltration system. You are likely well acquainted with the installation procedures for conventional elements, their sliding couplers, and vessel adapters. The procedures shown next will be similar, but certain differences will become apparent to you as you watch the installation process. The sliding interconnector has become the industry standard for connecting elements. The interconnector relies on O-rings that slide into place on either the interior or the exterior surface of the center tube. Unfortunately, the parts don't always slide together smoothly, and the O-rings are sometimes unknowingly pinched or rolled during installation. After installation, sliding action wears down the O-rings, which can lead to leaks. Sliding interconnectors also cause unwanted back pressure by restricting the flow of permeate. The interlocking end cap provides a new method of connecting elements. A key advantage is that it dramatically reduces the number of O-rings required in a system. A single O-ring provides the seal between adjacent elements. Furthermore, the elements are firmly locked together in a manner that prevents pinching, rolling, or abrasion of the O-ring. A key physical difference between a conventional element and the interlocking element is the use of interlocking upstream and downstream end caps. The upstream end cap is larger, and it includes both the brine seal and an O-ring seal near the center tube. The O-ring is axially compressed between adjacent end caps. Because there is no sliding motion, lubrication of the O-ring is not required. The end caps make a distinct snap when properly locked together. This snap tells the installer the O-ring is compressed and the connection is now leak tight. A visual indicator of proper connection is also provided. Simply verify that the external markings are properly lined up across the connection. This presentation will illustrate how two operators use the recommended methods for installing interlocking elements. The special tools shown here are optional, but we recommend them for safety and to prevent damage to the membrane elements. As always, steel-toed shoes, gloves, and safety glasses are recommended when handling reverse osmosis membrane elements. First, prepare the vessel by installing the downstream thrust ring and end plate. For easier loading, the vessel may be lubricated with glycerin or approved lubricant. Next, attach the downstream vessel adapter to the first element that will be loaded into the vessel. The recommended strap wrench has a heavy-duty rubber strap that grips the element securely, but will not damage the element outer shell. The wrench is lightweight, durable, and safe. Insert the first element downstream end first and push it into the vessel in the same direction as the feed water flow. Leave enough of the element protruding from the vessel to allow attachment of the strap wrench. This is a good time to check the condition of the O-ring. Attach the second element, taking care to hold the element horizontal when applying clockwise torque. Rather than gripping the outer shell, apply torque by gripping the spokes on the upstream end cap with one hand while supporting the element with the other hand. The strap wrench should be secured to prevent rotation. After the elements are snapped together, verify that the markings are properly aligned. By the time the third or fourth element has been installed, the strap wrench may be unnecessary. The strap wrench is only required until friction generated by the installed elements is greater than the force required to snap the elements together. Push the elements deeper into the vessel. Repeat this process until all of the elements have been installed in the vessel. Finally, add the upstream vessel adapter to the last element and push the elements to their final position in the vessel. Apply lubricant to the adapter and add shims as required. Operators producing ultra-pure water may choose to omit the lubricant. The job is completed with the installation of the vessel end plate. The final portion of this presentation illustrates recommended methods for removing the interlocking elements from the pressure vessel. Once again, the special tools shown are optional, but are recommended for your safety and convenience. With the vessel end plate removed, the downstream vessel adapter can be disconnected. This is done by reaching into the vessel and applying counterclockwise torque to the downstream adapter. Attach the optional pulling tool with a clockwise twisting motion. Pull the stack of elements far enough out of the vessel so that the first element can be safely removed. With the element supported, decouple the element with a counterclockwise twist. Sometimes it works best to face away from the vessel when unlocking. Repeat this operation until the vessel is emptied. As an alternative to pulling the elements from the vessel, the entire stack can be pushed from the opposite end of the vessel with a push rod or with replacement elements. After the last element is removed from the vessel, disconnect the upstream adapter. For your safety and convenience, keep the following tips in mind when handling iLEC interlocking end caps. The downstream end of the element must be installed first. Double check the O-ring before locking elements. This is your last chance to check the condition of the O-ring before installation. Make sure the alignment marks are indeed aligned. This ensures that the elements are snapped securely together to form a leak-tight seal. If there is an arrow on the element label, make sure the arrow points in the same direction as the feed water flow. Finally, remember to keep the element close to your body and apply torque by gripping the end cap. Do this when you load and when you unload. In conclusion, iLEC interlocking end caps offer benefits that can help reduce your system operating cost and reduce the risk of O-ring leaks that cause poor water quality. These benefits include long-term seal integrity. The single non-sliding seal reduces the number of potential leak sites and eliminates O-ring abrasion. Leak-tight startup performance. There is no possibility of O-rings being pinched and damaged during installation. Lubricant-free operation. The non-sliding, axially compressed seal enables full performance sealing between elements without the use of lubricants. Backward compatibility. Elements remain compatible with slip-fit connection methods and current pressure vessel designs. Immediate installation feedback. An audible click and matched alignment markings verify a leak-tight seal is achieved upon installation. Reduced permeate pressure drop. The new end cap design imposes less permeate back pressure. Durability. Tests have shown that the interlocking end cap connection withstands bending, sacking, and rough handling from repeated installation cycles. Easy loading and unloading. Element loading and unloading requires no additional time or personnel. Thank you for your time. With our eye on creating breakthrough solutions for the water industry, we've developed iLEC interlocking end caps to help you deliver the highest quality water at the lowest total cost.